Hello, and welcome to Future-Proofing Data Management, the Case for Kubernetes. This webinar's sponsor is Portworx by Pure Storage, and the session is produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I am excited to be your moderator for this special event. Now, before we get to today's great content, we have 4 housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. So not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will usually fix most audio, video, and slide advancement issues. But if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a link for getting started with Portworx. There are also some links labeled ATM, which stands for Actual Tech Media. So there's some things for you to check out there. So I encourage you to access those resources now and share them with your friends and colleagues. Now, third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the link with the details there. Now, finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. And with all that out of the way, let's get to today's great presentation. So it's my pleasure to introduce you to our presenters today. We have Eric Shanks, who's Principal Technical Marketing Manager at Portworx, and John Owings, who's Director for Cloud Native Strategy at Portworx. So now I'll turn things over to Eric to get us started.
Hi, good morning, good afternoon, good evening, good middle of the night, good whenever you're watching this webinar at your own pace. Thank you for joining us. Today we're going to be talking about future-proofing your data management, the case for Kubernetes. So during the course of this webinar, we're going to be talking a little bit about the common ways that people are managing their data for their Kubernetes applications. And we're going to show you the way that Portworx thinks is the best way to manage this for multiple environments. I'm joined today by my esteemed colleague, John Owings. John, would you introduce yourself?
Hello, I'm John Owings. I've actually been with Pure Storage for over 10 years now, but now I work with our cloud native strategy and get to talk about containers and Kubernetes and data on Kubernetes all the time.
Thank you for joining me today for doing this webinar. And my name is Eric Shanks. I'm the Principal Technical Marketing Manager with Portworx. I've only been here for about a year and a half, but I focus on the cloud native strategy here. John, just to let you know here, I chose these 2 poor quality images for us here that look like they're stretched out so that when people saw us in person, they would see how much more amazing we look in person. So you're welcome for that.
Thank you. Thank you. When people say you lost weight, I'll be like, yes, of course.
Exactly. So let's look at the agenda real quick. We're first going to talk a little bit of a Portworx primer. So we're going to give you an overview of what Portworx is and what it does and why we exist. And then once you've got that kind of explanation, then we're going to look at some of those ways that people are managing their data for Kubernetes in traditional aspects. So we're going to start focusing on things like hardware storage arrays and using the CSI drivers, how people are using public cloud managed databases, and of course, the tried and true method of using virtual machines that are running your databases. And we're just going to talk a little bit about those situations and things that may come up, things that might be problems for customers. And then finally, the answer to all these problems is to use the Kubernetes alternative, which is running your stateful applications on Kubernetes with the help of Portworx. Anything to add, John, before we get started?
No, I'm excited. So yeah.
Okay,
let's get it going.
So first off, a little primer on Portworx in case you're not familiar with what we are, what we do. We're a leading container data management platform for Kubernetes. So what we really do is we help you run your stateful applications in your Kubernetes cluster along with the rest of your applications that are maybe stateless, right? We're running both of those things for you. And the way Portworx works is we'll use any storage. So we're gonna exist in your Kubernetes cluster. There's going to be some storage that's either provided from either on-prem, from the public cloud resources, or at the edge. We don't really care what storage you're using as long as it's block. And then we'll attach those to your Kubernetes clusters, and we'll use that to make our storage cluster. We run on any Kubernetes distribution. So if you're running Red Hat OpenShift on-prem or Tanzu on-prem or something like that, no problem, we'll work with that. If you're running managed databases in the cloud, like Amazon EKS, Microsoft AKS, or Google GKE, we'll help you with that as well, right? So really we'll work in any one of your environments. And then Portworx lives in the Kubernetes cluster at this next layer here. And what we do is we help you automate, protect, and unify your applications, right? So in the automation space, we'll help you do things like expand your disks if you run out of storage space for your persistent volumes. We can do that automatically. We help manage a lot of your day two operations. From the protect standpoint, we do things like provide disaster recovery for your stateful applications in Kubernetes. So we can do synchronous DR or asynchronous DR, depending on what your recovery point objectives are. We also have a backup product to help back up those Kubernetes applications as well, since if you're running stateful apps in Kubernetes, now you also have to have a way to back up those applications. And of course, unify. John, I think there was an event that happened in the last several months that people started looking for ways to run their virtual machines in other locations. And we can help you run your virtual machines through the help of the KubeVirt project. And we can help manage your stateful applications for your containers and your virtual machines in your Kubernetes cluster.
And even manage the database, right? The database as a service. So
exactly. And then we'll run any database basically on top of that, right? So kind of an anything here, any cloud, any type of Kubernetes cluster, any stateful application will help you run those. To look at this in a different way, if you're a VMware person and maybe you've seen VMware vSAN before, a logical way that you can conceptualize what Portworx is doing is we're doing a lot of the similar things that vSAN's doing. So on the left-hand side of the screen here, you can see we've got a VMware vSAN data store. You've got a VMDK, which is your disk for your virtual machine, and multiple replicas. vSAN defines the number of replicas you're using with a thing called failures to tolerate. And in this case, we have a FTT of 2, which means there's 3 copies of your data. Portworx does a similar thing, only we're doing things for containers, and we don't require you to use local disks like vSAN does. You're allowed to use storage arrays, present a LUN to those hosts as well. And we're doing a similar thing where you can have your persistent volume, but we have replicas on multiple hosts so that we can protect from a failure on any one of those hosts. So that's how we kind of provide high availability.
3. It bothers me that 2 equals 3. That's just something that irks me.
Yeah, it's confusing. Our FTT of 2 equals 3 copies. A REPL 3 for us means 3 copies. Our way seems simpler.
Yes.
But Portworx Enterprise is providing you those storage capabilities that a typical enterprise storage array would in like a VMware environment. But we're doing this all inside of a Kubernetes cluster. So we're going to provide high availability through our replicas, and we'll do failovers across zones if you need to. If you're like in a public cloud and you're using availability zones, we're topology aware. We do things like manage volume placement services, which are a way to make sure that your pod and your replica are running on the same node, so that you can get better performance benefits out of that as opposed to having your volume on a different node from where your pod's at. We do things, we have a tool called Autopilot, which is our capacity management tool. So if you run out of disk space in your persistent volume, instead of your volume crashing, we can actually extend that volume so that nothing goes down. You get an alert that says that we expanded your volume and your containers just keep on running as opposed to having a failure. We also do migration services. So if you need to move your applications from one cluster to another cluster, we can totally do that. We'll replicate your data for you, and then when the data is replicated, we'll fail over the applications to the other side as well, which kind of brings us into disaster recovery. It's a similar method to migrations, except of course, in disaster recovery, you don't know ahead of time that you might have to actually migrate all of your applications to another cluster. And we do that through either asynchronous DR, which is a RPO of as low as 15 minutes, or we also have a synchronous DR solution, which is kind of like a VMware Metro DR cluster setup, where it's zero data loss, but there is a requirement that you have to be within 10 milliseconds of round trip latency between your two clusters. We do snapshots inside of our storage array in the Kubernetes cluster. We also have a thing called Cloud Snaps, which is a way for you to take those snapshots and copy the data up to a public cloud so that you can store it, or an S3 bucket. We do AutoFS trim so we can automatically reclaim some of your disk space. We have a solution called PX Fast, which allows us to take very fast, efficient use of our NVMe devices that are in your Kubernetes cluster, so you can get more out of the hardware that you've got. And we do application I/O control for things like noisy neighbors, right? If you got two pods that are also really requesting a lot of storage, one of them might be taking up all the resources and starving the other pod for resources, we can adjust that as well. A typical enterprise feature that you'd see out there. And we do security and encryption. So we can secure your data, make sure that they're authenticated, the pods are authenticated to make sure that they're the ones that are allowed to access your persistent volumes. And we can encrypt that data as well, because obviously encryption is paramount at this point in our lives. John, did I miss anything?
Oh, that was very comprehensive, Eric.
Thank you.
I feel like you did a job. One thing is, I call that autopilot. That's my operational save, right? Like, those things only fill up, like a database only fills the volume at 2 a.m. So I love not getting paged in the middle of the night about things. So that's my save, get my life back part of the product.
Yeah, probably my favorite feature. I did leave one out, volume trash can. One of our TMEs will be upset that I didn't bring it up. It's kind of like recycling bin for your persistent volumes. Accidentally deleted a replica. Well, there's a time frame where we'll still allow you to restore that. The last slide on our Portworx primer, I don't want to bore you too much. We've been doing this for a while. We're pretty good at it. IDC recently, in the last 6 months, put out their first container data management marketscape. And as you can see up there towards the top in the leaders section, you can see Pure Storage listed. So this is just to show you we're pretty good at this. We know what we're doing. We've been doing this for a little while now. Okay, so let's jump into the main part of our webinar today. And John, I was wondering if maybe you would walk us through this section here. I'll run the slides for you. So we can just talk about why hardware storage arrays are troublesome in some cases.
Exactly. So when we're talking about hardware storage arrays, we'll just kind of level set when it talks about like what new applications or modern apps or whatever we're going to call it today mean, right? And that is, new apps are loosely coupled microservices. Usually we break those apart using containers. They're managed in, life cycle wise using, DevOps practices or, platform engineering. And they're made to be dynamic and elastic, right? They need to scale, they need to connect, disconnect, move from place to place. And the problem with that is the way that you traditionally use an array, and I'll kind of try to put an emphasis on traditionally, is that they're made for, hey, you attach a VMware data store and you leave it. Then all those operations happen inside of VMware. Or you attach an Oracle database and it's there, right? And it runs. That's what it's made for, and it's good at that. But they're not managed by the DevOps teams. They're not made to be used via API in general, right? There's a lot of people trying to do that. Storage arrays are hard to scale across multi-cloud and edge. Like, it's really hard to scale a physical device from a data center out to a manufacturing plant or over to a public cloud provider. That is a difficult thing, if not impossible to do. So we can go on the next slide.
Yeah, kind of hard to talk about cloud native when we're talking about a hardware appliance all the time, right? That seems to be the opposite of what cloud native typically means.
Yes, we want to keep that tenet of cloud native, which is able to be dynamic and move around. And why not? Like, why shouldn't we do that? Like my storage array vendor, said I should do it this way. Migrations between environments are, they require similar types of storage. Like you can't replicate a NetApp to a Dell, right? Those things don't compute. Cloud vendors don't always have the same type of array. Those services may not be, some of them might, but they may not be available in the public cloud if you're moving there. A lot of edge locations do not support, you can't put an array maybe in the back of a tractor or in a meat processing plant. Like there's things that physically you just really hard to get the power or the space or the environmentals. Even if you have the power and the space, if it's 170 degrees inside that room, it's really bad for storage arrays, especially disk arrays. I'll tell you that much. And edge locations, they don't work. I just said that mixing storage arrays across sites is very complex. And the team that runs the application doesn't have the access to run or own that storage. So that makes it difficult, right? So there's a lot of having to pass things back and forth, and that makes it inflexible. I would say there's one word to summarize this. The big point is it's inflexible. So we can go on to the next slide. And this kind of gets into the architectural differences. And it's a big one, right? Is that hey, everyone out there is going to say they have the checkbox for Kubernetes, and they call that CSI. Well, Portworx uses CSI, by the way. It's just a spec. It's just how you get storage from a thing. Now, the way that the traditional vendors have implemented this is in a way in order to force you to have, one LUN, and that can map to the concept of a PV within Kubernetes, which is then a persistent volume claim is what maps it to the container. And it's very nice and clean, right? You have a container, you have a LUN. You have another container, you have another LUN, right? With Portworx, what we do is we actually take those LUNs, we build a pool out of it, and those actions that happen for the PVs is all done within Kubernetes. And at this scale, it looks kind of the same, right? I think we move on to the next slide, we may see a slight difference. So as you scale, this becomes more and more complex. You get a lot of connections. You can see with the, both of them are, showing a hardware storage array. That's providing block. We have no problem with block storage. The problem is all these connections. And when you start to have this many connections, you will eventually, I think we got to build on this, is you'll eventually run out. Either the host will run out in the cloud, they have certain limits. There's only certain things SCSI will let you do. And it becomes an issue at scale. Now, and when I say at scale, I mean, this is 3 nodes. This is not gigantic. We're not talking about 10,000 nodes all at once. We're talking about, hey, I have dozens of containers, which can happen very, very, very easily in this world, right? You scale something, that's what it's made for. It's made to scale. That's why you're using this platform. And with Portworx, right, we don't have that same pressure of number of connections because we have virtualized that into Kubernetes. When I say virtualized, it's not a VM, right? We're just talking about it's abstracted. It's abstracted into Kubernetes. It's all done within there. And within the host itself, the data, we handle the protection, right? With that, part of the, Portworx platform that we were talking about earlier is we protect it. We make sure it's in the right place at the right time, but you don't end up with these connections that are going to eventually become a problem. Now, you look at it right now, if everything's static, it's okay. But as you grow, you're going to start to see some differences. We can go on to the next slide. And here's some tests that my good friend Eric ran a while back, right? And what this means is these are CRUD churn. I love the term CRUD because it's kind of really emphasizes what it is, right? These actions that are happening, right? And with Portworx, right, it's very stable as you grow the number of pods. So you can see 0 to 200. Hey, we have this much, all the way up to 600 plus pods and PVs. So each one has a PV. You can see how it stays fairly level. If we start averaging these out, Portworx should stay about the same. And it is for the most part here in this graph. But you can see any hardware array, it reaches a breaking point. When you start to see all those lines like we had in the slide before with all those host connections, it eventually, it looks like it's scaling, and then it reaches a point where it just breaks, and it just keeps repeating those things, and it just shoots off into everywhere. And you're going to get failures. You're going to have problems failing over. it's going to make your life hard. It'll be a Sev1 type war room phone call with all the vendors trying to figure out why you're down hard and losing money. So go on to the next slide. Actually, I think
Yeah, I
that's
think that was
right?
it
No,
for storage
throw it
arrays,
back
but I
to
had a
you.
couple things I just wanted to mention, John. I think you did a great job here, but like this connections issue in my head, partially, I think these connections issues are probably not going to happen to me. Like I'm not worried about them. But as we were like looking into like the number of connections you can have per node for like an iSCSI connection to your storage array or whatever, those numbers are actually really fairly low. Like I was looking at some of Amazon's connections for the number of EBS volumes, and I think they average around 30. Now 30 is probably a lot of storage connections, but 30 is not a lot of storage connections when you're talking about containers and container pod densities and scale, right? So you could have 100 pods on your node, right? But not all of those pods are going to be able to run a persistent volume if you're using the traditional CSI plugin with an external array because of that host connection limit. And I think one other thing that we don't really think about all the time when we're first looking at this is what happens to me when I have a host failure? A host failure, those volumes are already created. The storage array has basically already done its work to create the volume, but there was a host failure or something. And now all of those pods need to be restarted on a different node and they have to connect back to their original volumes. So that means there's a lot of disconnect operations that have to happen on one host and connect
A long
operations
time
that
out.
happen
It could be a
on
very
another
long
host.
time out too, right? Those disconnects, it can sometimes it's the operating system or the Kubernetes will want to wait and make sure it's really down. Before, so you may be waiting a lot longer than your business wants you to. We'll put it that way.
Yep. And a lot of times we see this, it takes longer than 5 minutes, which feels like an eternity when you've got some sort of an application outage and you're just waiting for Kubernetes to restart applications and things, right? So one of the things I guess I wanted to press upon was think about what happens if you have a failure. Are you going to be able to recreate those connections? And an iSCSI connection takes a long time in comparison to a lot of other operations that we typically do just deploying things, right? So that's one thing to think about. But I had a question for you, John. Knowing what we know about, like what we just talked about with external storage arrays, why do people use an external storage arrays with their Kubernetes cluster when they get started with a new project?
Usually because it's what's there, right? They have an array, they have a thing, right? They have a plugin, and their vendors, has given them that, right? And honestly, like it comes down to at a certain scale, a certain small scale, they don't know the difference, right? You're just getting into it, and as you start to go, we see time and time again customers that just have, oh my gosh, I got to this point, and now this is not good, right? I had a downtime. This did this, right? And how can you help us, right? And we come in, and we show them how we work, and what I would love is for more people to start with Portworx, not just because we work for them, but like it would really save you some of those bumps along the way in the journey of using Kubernetes.
Yeah, that's exactly what I was thinking. I think you're going to see a similar theme as we go through some of the other sections. But like if you were going to do a design for your new Kubernetes application, you're just getting started with Kubernetes. You haven't been doing this for very long, and you've got your storage array already available to you. The storage array becomes a constraint as a part of your design, right? So you just bake that in and just start moving forward with what you have in-house. And I think in this specific case, as you mentioned, it may be better for you long-term to think holistically about what you want your Kubernetes platform to look like and whether that includes a data platform with it, or if you're just plugging in some storage array that you have laying around, right? That kind of thing.
Yeah.
Okay, so I think we hammered on storage arrays enough. Let's take a look at a common way that people are doing this in the cloud. So I've got my Kubernetes cluster out in the cloud. My containerized applications are very portable. I can move them from my on-prem location to the cloud, to the edge, back, where, on my local desktop, wherever I really wanted to run my applications. But as soon as you introduce state, now you are kind of tethered to that state. And in the public cloud, the same thing that we were talking about on-prem with using a storage array, because that's what exists, If I got started today and I was using, say, Amazon EKS to run my containers, what would I use for storage? Probably the thing that's right next to my Kubernetes cluster. And Amazon's got plenty of managed databases, right? So I would, in a lot of cases, just get started by using a managed database because it's quick for me to get started. I don't have to manage a lot of things. The managed database is doing most of that work for me. I just have to tell it like sizing and like what kind of database I want it to be, and I'm golden. But when I do that, I'm now tethering my Kubernetes cluster to the cloud and my applications to that managed database, right? So it acts a lot like a boat anchor that's holding our applications in place before they were very portable. So let's look at a couple of examples here. And here I've got two Kubernetes clusters, and I'm deploying my application into those two clusters. If you're wondering why the application looks like a pig, that's because the technical marketing team commonly uses a made-up Portworx barbecue company with their own applications for us to tell stories. You can even see I'm wearing my Portworx barbecue sweatshirt here for the festivities. So I've got my application running in two different Kubernetes clusters in two different clouds in this case. Now the Portworx barbecue application requires a MongoDB backend to store state about our barbecue customers and orders they've made and things like that. Now, in these two clouds, they both have managed databases for MongoDB. Amazon has AWS Document DB, and Azure has Cosmos DB. So I can still use a managed database. And now I've introduced one difference between my application in these two different clouds, right? Before I had everything the same, but now I've got to manage two different databases of a similar flavor. Now, John, I don't know about you. I don't get scared about running two different types of databases. I've been a system administrator, or I've had to run tens of different types of databases, right, in the past, and we found a way to manage those. But it's some toil, and there's extra things you have to learn. So I want to think about the other things that are involved in this, right? It's not that I'm just managing two different databases. If I'm in AWS, I have to manage identity and access management policies. If I'm in Azure, I'm not using IAM, I'm using something called Azure AD. So now I've got another difference that I have to manage just to run the same type of database in two different clouds. It goes a little further than that, though. I've got to have a VPC in Amazon for my database to live in, and I have to connect it to my applications. In Azure, I'm using a thing called a VNet, and they work slightly different. In AWS, I have to manage a thing called a security group. So it's my basic firewall port rules things, right? In Azure, I'm using network security groups, which are, again, very similar, but different API calls, a different structure. Things are slightly different. I have to manage AWS backups to back up my database. In Azure, I'm using Azure backups. They're different. And if I'm doing snapshot replication for, like, I need a disaster recovery solution, Amazon's going to let me use snapshot replication of my database. I can snapshot it, replicate it, I think over S3 to another region or whatever, and then I can restore that data. And in Azure, you might use a global distribution where Mongo is actually split across zones, and a failure in one zone means that your application is still running in another zone, right? The point of this slide really is to show you that we're not just managing two different types of the same database. We're managing a whole suite of different services from those clouds just to run that database when all we really wanted was a MongoDB database, right? That's my point. And in the Kubernetes clusters, our platform admin or platform engineer, someone is running our Kubernetes environments. But the rest of these topics probably require at least one cloud admin that you have to pick up the phone and call or open a ticket or send a Slack message or something. And maybe you've got two different cloud groups that are managing the individual clouds, right? So this gets to be very cumbersome from an operations standpoint just to manage the databases that you're providing for our applications. Let's take that one step further. So now we use a different application that we typically use here at Portworx to do demos, and this one's called Portworx Delivery. And this one's a little bit more complicated application. It still uses MongoDB for authentication purposes, but we also use a queuing system to handle orders, and then those orders eventually filter into a MySQL database. So we've got 3 different databases here for this one application, which is a common thing that we typically do for a microservices type application. You might see many databases for microservices versus just seeing that one database for like a monolithic app. In Azure, we can build the exact same thing that we built in AWS, but we're using 3 different services. So AWS is DocumentDB, RDS, and SQS. We can still build the same things in Azure with Cosmos DB, Azure Database for MySQL, and Azure Message Bus, right? That's their queuing service. So we could make this work in 2 different locations. But the point is, we already learned how many other services that you have to manage for a single database. Now imagine doing that for multiple databases. And again, this is only one app. If I've got multiple applications to manage, I've got multiple other services that come into play, and it causes toil. There's a lot of problems with that.
You guys like writing code about food. That's what I've noticed so far today.
It is. I get hungry every time I code something. Okay, so let's bring it to our third situation that customers typically use, and that's virtual machines. So I guess, John, let's start with, why do people use virtual machines to run their databases?
What they've been doing for 12 years, I mean,
Yeah.
or more. So it makes sense, right? And they already have all these processes and people set up, right? And it's super easy.
Exactly.
Super, super easy. But you're going to tell me why.
Well, I mean, we've run databases in virtual machines, probably a lot of us, our whole career, right? It's hard to then say, well, there's a new way that I can manage these databases. It's also very hard for us in a lot of cases, if you're a virtual machine admin, to say, I'm going to go learn Kubernetes. Not everyone has made that jump. I think eventually there will be a lot of people that have made that jump, but for right now, maybe they haven't. But think back to when we were doing things with virtual machines and all the other teams that we had to manage.
Yeah, exactly.
Now I've got,
we call that operational complexity. It's like a web of people up there to me, right?
Exactly right. So, again, if I'm a platform administrator, I can manage my Kubernetes cluster, and I can manage everything in that Kubernetes cluster. But if my database isn't a container, my database lives in a virtual machine someplace else, it might live on different infrastructure, it might live in a different zone. And now I've got all these other teams that have to have some input or some manner of work that they have to do so that they can connect my applications, which might be spinning up and spinning down constantly, to a database that's living on a pair of servers, right? So if I need access to the database servers, I might have to talk to a network team to open firewall ports for me, or someone to set up a load balancer for those databases as well. I don't know if that's the network team or another team, but there's a team involved in that. The security team's going to want to be involved in like where you store credentials for your connection strings to those databases, right? There's a storage admin that's still going to be providing storage from probably an array to those virtual machines, possibly like RDMs or something. So there's a lot of work that has to go into that. And then, of course, there's a server admin that makes sure that the servers, are up and running and fault tolerant and highly available, and they're running on performant hardware, and they may have to be responsible for some of the patching of those servers and things, and managing downtime and all of that. There's a lot of people involved here.
One other thing I was thinking of while you were talking about this, sorry to interrupt, but is I just imagined they all have to do their work, then they all have to go to a meeting and talk about it, and then do change management meetings about everything that happens in between, right? And so this process, even though maybe it's 10x faster than it was, 25 years ago, it still, it encumbers a lot of innovation. In my opinion, right? Like you got a lot of things happening and a lot of people that need to work together, which is hard.
Yeah, exactly. There's so many communication paths that have to be here that it's going to slow things down, even if they've automated a lot of these processes, right? Conway's law is going to kick in at some point and say, look, there's more people here. It's going to take longer to communicate all of the changes and things that happen. And that's one of the things we're really trying to avoid so that we can accelerate our deployment velocities and things. Of course, if we were doing this on Kubernetes, if you're using a solution like Portworx's data platform to manage your stateful applications, and you could run your databases in your Kubernetes cluster, then your platform administrator can basically do all of this for you, or your platform engineer, whatever that title is. You can manage your secrets in Kubernetes if you want to, right? You could use a Vault plugin or whatever inside Kubernetes and manage your secrets. Your storage comes from Portworx, from the storage array. You've got network policies that you can put in place if security is worried about the applications talking to the databases directly and nothing else. You can manage all of that stuff in Kubernetes. And of course, Kubernetes is doing service discovery with like Kubernetes services to load balance traffic across your applications. And if an application crashes and a new one comes up, the service will find the new application, right? So you get a lot of benefits just from running all of these things in one platform. And some of those aren't technical benefits necessarily. They're operational benefits that are about how your teams work with each other. So I think basically everyone watching this webinar at this point knows that our solution is running data in Kubernetes or on Kubernetes, however you look at that. Let's take a look at some of the optimizations and things you get out of this. So in 2022, the DOK report came out at the end of 2022. They haven't done one in 2023 for whatever reason. But one of the things I found in that report where they interviewed a bunch of people that were running data on Kubernetes was the fact that they got better at productivity just from starting to run data on Kubernetes. And it's not so much that people are getting more productivity from running data on Kubernetes. It's that this lagging section, the section on the right side, you can see that people that are just getting started with running data on Kubernetes are starting to see these benefits. And they're not probably a very mature organization, right? They haven't gone through lots and lots and lots of revisions of this. They're just seeing these benefits early on, right? So you're seeing 51 respondents here basically are getting 10% or more productivity benefits just from running data on Kubernetes. And 35 of them are getting 50% more productivity, right? So to me, that's a compelling argument for some real world examples of people saying, look, I get actually benefits out of this. Going back to a slide we talked about earlier, John, you were mentioning like storage arrays. Storage arrays can't replicate to every location, right?
Yep. Usually it's only where they are. Like to like, right?
Right. So I need your example. I think you said like I can't replicate a NetApp to a Dell, right? If you're using Portworx or a software-defined platform in your Kubernetes cluster to manage your containers data, that kind of goes away, right? So a storage array on-prem, I imagine most of our customers already have storage arrays on-prem for something, right? We can continue to use the storage arrays and just present LUNs or volumes up to those Kubernetes nodes, and we can create that Portworx storage cluster in your Kubernetes cluster, and it'll look exactly like the storage clusters that are in all of your other environments, right? If I've got a public cloud and I'm using, say, Amazon EBS volumes or Azure disks, I can create a Portworx storage cluster in that cloud that looks exactly like the one I have on-prem. And the problem that we had at the edge where you're mentioning that we can't have storage arrays in all of our edge locations because there's not power, cooling, possibly money, security, multiple reasons why you might not be able to get a storage array at the edge. You can use local disks and some pizza box servers if you really had that. And you can create a storage pool there that looks exactly like the other two environments. So what you're getting to now is you're really at a platform level where each one of my environments looks identical, and I'm starting to get some efficiencies on how I'm going to manage my environments because I can run something on-prem and run something in the cloud and run something at the edge, and all of my deployment processes, all of my troubleshooting steps that we may have had to write down in a wiki or whatever, they're all the same. So now we're starting to be able to run these environments with fewer people And I think one other thing that I like to look at here is, what about hiring practices? So, John, if I was going to run applications in AWS, I might have a whole list of requirements for that engineer that I was about to hire, right? Oh, they need to know ECS, or they need to know S3, or whatever services that you might be using to run your application, or even the managed databases. Do you know these managed databases well enough to run this for a company? It might be easier now to find people that have Kubernetes experience, and they'll work on any one of your environments. So it might actually make your hiring process a little bit better.
That would be nice, right? I'd like to throw something else in here too. I know that we could talk for like 2 hours, and you and I would just go on and on.
Yeah.
But what I don't want to distract us too much is that even if the arrays are the same, if you're using that connection method that we were talking about earlier, right, where you have a CSI connector and you have that one-to-one mapping, some of them will replicate that data, right? You have another array. So it's not even like, hey, we have a duplicate of that, whatever brand it is. Kubernetes doesn't know what that is, right? It doesn't know, hey, yeah, the data's over there, but that is a manual process to bring that up. Like either you have to run a special tool or script, which is super awesome demo on YouTube. You can probably find them out there for one app, but you do it for 10, 100, 1,000. It is a massive mess to make happen, right? Because those volumes aren't what Kubernetes wants them to be called, all kinds of things. So just think about that too. It's like, while Portworx is awesome for being able to spread across different types of block storage, even if you have all of that one vendor, Portworx is still going to make your life so much better.
Yeah, exactly. It's a similar argument to earlier when we were talking about connection limits. You're kind of getting away from some of those issues. When you have that scale, you're going to see those issues pop up more and more, and you won't see that necessarily during a proof of concept or your MVP scenario, right? You're going to get everything running and you're going to, hey, look, we can do this. But once you've got hundreds of these things running or thousands of these things running, can you still manage these applications and this data in the same way? And I think in most cases, we're finding customers find out that at scale, they're having the issue, and that's when they come and talk to us. So here's my pitch, basically. That complicated application we talked about earlier, where we were running a queuing service and a MySQL database and a NoSQL database, we can run all of that in Kubernetes, and it looks identical no matter where I'm going to deploy it, right? I build my Kubernetes manifests and artifacts and all of these things. I store them in Git. And when I want to deploy my application, I just run my deployment scripts against the Kubernetes cluster. Kubernetes is my application platform, and it's going to make sure that I have the same capabilities and functions and features in all of my locations, as long as I'm running Kubernetes and it's conformant Kubernetes, right? My platform admin can do all of this work for me now. So I'm getting some benefits of not having to pick up the phone and call someone or troubleshoot with another team because you can't see everything or you don't have access to everything. And then Portworx kind of sits down below inside the Kubernetes cluster. Just like your Kubernetes cluster is your app platform, Portworx becomes your data platform, right? So now we can do those same types of things. We can run databases in Kubernetes, and we get all those enterprise features that we typically get from a storage array, but we get it in a cloud native way. So I think that's my main pitch here, is make it easy on yourself. Learn how to run this one time in your Kubernetes cluster and then replicate it to any one of your environments. And it's going to be a consistent way to manage your applications, right?
Yep.
And in this case, we've got Amazon EBS volumes, which are block-based, and Azure disks, also block-based. We present those to the Kubernetes cluster. And then Portworx is that storage cluster inside that Kubernetes cluster. And we can do things like replicate the data between those two clouds if we need to, right? If you're going to do a migration, or you're worried about disaster recovery or whatever, or you're just worried about things like cloud lock-in or whatever. I've also heard on-prem that customers sometimes have a multi-vendor strategy, right? They're worried about, one storage array vendor starting to hire up their prices or not give them the beneficial prices or whatever because there's some lock in there. So they go with multiple vendors so that they can kind of get around this. It might be a good strategy, but operationally, it makes things more cumbersome. This gives you a way to continue to use that multi-vendor strategy and just put that software layer on top of them to give you consistency across all of your environments. And then you can go buy whichever vendor's got the best deal for your company.
And those CSI connectors that are created by each vendor, those proprietary plugins, they don't give you a way to migrate to another array. They don't have like a button that says, "Hey, I'm finished with my whatchamacallit. I'm going to go to the new thing," and it moves all the volumes and stuff. It's not, especially when it's another vendor, it doesn't work that way.
Yeah. And particularly with Portworx, one of the things I like is we're not just replicating your data. When you do a migration, we'll migrate the Kubernetes metadata as well. So your applications that are using that data can also be migrated at the same time. So it's very similar to to VMware Site Recovery Manager. If you've ever used that, you push a button, your data gets a one last sync if it's online, and then your VMs come up on the other site. Works pretty similarly, only we're doing it with containers.
The objects are there. You just have to tell them to turn on. That's what's pretty awesome.
Exactly. We also have synchronous DR. So instead of replicating that data on set intervals, you can replicate this data immediately. So the data is committed. It's written to two different locations before it's committed back to the application. So we can guarantee zero data loss. As long as you can deal with the 10 milliseconds of round trip latency, which you may or may not be able to do between cloud vendors, right? This is typically for like a campus environment or something.
Yes.
So we've been talking about like the Portworx platform, and up till now, we've really been focusing on like that storage, the software-defined storage layer that sits in Kubernetes that we use to provide all of those enterprise capabilities to all of our environments. But, I'll be honest with you, a lot of places are using cloud managed databases because they don't have to manage it. It's not something they want to spend time on with managing those databases themselves. So there's a reason why you might use a managed database, even if it may not fit all of your environments, right? I'll admit that. So one of Portworx's platform solutions is called Portworx Data Services. And Portworx Data Services is a way for us to provide you databases as a service from a managed portal, but they run on Kubernetes. So we can get away with doing this because Portworx Enterprise, our storage layer, is providing you all those enterprise capabilities to make sure that your databases run well. The next step is just, let's provide a service to customers where they can go to a portal and say, I want this database deployed to this Kubernetes cluster and manage it all from a managed portal. So we're taking away some of those tasks that would typically be involved in like deploying operators and deploying individual Kubernetes clusters with certain updates and like how do we patch those later. Portworx Data Services can help us manage that in one place and do all of the lifecycle tasks. And I think we've got a demo coming up here, unless there's something else you wanted to mention here, John.
No, we're good.
Okay.
The demo, if we play it, is my demo, right?
Yeah.
Yes. So this is PDS, as we call for short. You want to say go?
Yep, hit and go.
Go juice. So we're just going to look at like what it takes to deploy MongoDB. So we're going to select a version, give it a name, hopefully something awesome. Yep. PX barbecue, because we love barbecue. Choose your namespace. That's where it's going to deploy to. The target right there we didn't choose, but it's going to be the cluster. So you can have multiple clusters in different clouds. That's awesome and easy. And then there's application configuration. That's just a template of settings that you set beforehand. And then finally your resource size. So I want tiny Mongo. So that's just one node, but I can do bigger ones. I can add number of nodes, those types of things. And it really comes down to how much CPU it's going to use, how much memory, and how much storage, right? So tiny, You can see there, if you look really close, 5 gigs of storage. That's per node. So there's 2 on that one. So in total, it'd be 10, right? We're then going to hit some of these storage options around your replication factor. All this is preset and very easy. So if you know how to point and click, you can do this, right? You get something a name, you can make a database, which is pretty awesome, right? And we hit go. Well, we did backup job too. So the full daily at 1 a.m., we're going to make a full backup of this application, right? And it's ready to go. So it's going to take a couple minutes, I would think. Maybe we sped this up slightly, but it will roll out the container, bring them up, do all the settings. It'll actually set the load balancer for you to connect to it, and then give you the username and password to use it. So pretty straightforward. If you know how to use any kind of UI, you'll be able to figure this out in about 10 minutes.
Yeah, and one of the things that's not part of the demo is really those day 2 operations. Like deploying the application might not be the hardest part of everything, right? But once the application is deployed, what happens when there's a new version that's out? What happens when I need to scale out to 3 nodes instead of 2 nodes? All of that's available right from the GUI. You want to take an ad hoc backup, you can do that. You want to scale up the nodes instead of scaling them out, we can do that. So there's a lot of things.
Out with a new version of Mongo, it'll have a little note next to it saying, "Hey, it's time to upgrade," and you can see that, and you hit go, and it'll go.
Right. So to me, PDS is a great way for you to manage your applications and your data in a managed way still, but still using Kubernetes in all of those environments. And we're getting, again, some consistencies there and reducing that toil of talking to other teams and having meetings and scheduling things with other teams about outages. And all of those things now can be managed by a platform engineer who's probably got tons and tons and tons of environments or systems to manage, right? The last demo we want to show is, here we go. So this is our PX delivery application that we have mentioned a couple of times earlier. And this is just using PDS as well. But in this case, we're doing it from a command line. And this is basically just a simple Python script that's using the RESTful API in PDS to deploy those 3 services that we needed. Remember, we needed a Mongo database, we needed a MySQL database, and we needed a Kafka queue, right, for this application to work. So we can request those all from the command line, or if I was in an enterprise, I would probably be doing this from like a CI/CD tool or Jenkins or something like that, right? And it could deploy my databases for me automatically. Once those databases are done, we're gonna wait. So right now we're waiting for those services to become active, right? It takes a little bit of time to deploy, although not as much time as you might think since they're containerized and there's no data in them yet to start. Once the applications get deployed, they spit out that secret that you were talking about, which is our connection strings. So we can mount those secrets with our application as part of that deployment. And then we'll know the connection strings for our application so we can connect to each one of those data services that we've deployed, right? Looks like we're done here. The databases have been deployed. Let's deploy our application. And that's just done through Helm. So we've got a Helm install PX delivery in the PX delivery namespace.
And that's just the front end pieces.
Correct. Yep. And this is just to show a full demo. So we'll do a kubectl get pods on the PX delivery namespace, if I spell it right. And you can see all of my pods are running. So you can see Kafka and MySQL and Mongo and our PX consumer pod, which pulls things out of Kafka and pushes it into MySQL, and the actual web app. Now, what's going on here is in those 2 command line shells here, you can see I'm going to be running logs, I think. So kubectl logs on the application itself in the top one. And you can see we've got things going on. We're overlogging some things, so don't worry about the health Z. And then we'll do logs on the consumer application as well, which is what's pulling the data out of Kafka and pushing it into MySQL. So now we will pull up the application itself. maybe. So our application's up and running. We're going to register a user. So registering a user is going to push data into our MongoDB database. So we'll make up a fun user here, which will go into our MongoDB database. And this is just to prove that that connection is working correctly. Speed this up. And when we register, you can see in the terminal window, there's some connection strings and some information about the fact that we just did a post command, right? So that data is now in our MongoDB database, and we logged the connection string to show that that happened. Once we've registered a user, now they can go in to order some food from our barbecue place, and they're going to get smoked brisket, of course, and the pork special. And when they place that order, you can see in the top terminal, the data has been pushed into Kafka. And then in the bottom terminal, you'll see that we're actually consuming that out of Kafka and pushing it into MySQL. So this is just to show you a simple way where your applications with a quick script to deploy your data services and a Helm command can deploy your application, and everything is up and running and working. I could change the environment here to AWS, EKS, or Tanzu on-prem or whatever, and it's going to work exactly the same way in all of our environments. So with that, I kind of want to leave you with a couple things. First, we've got a really good interview here that was done by our general manager, Murley, along with Ford, and they're talking about platform engineering and how Ford's using Portworx under the covers in some of their environments. It's worth a watch if you're looking to learn more about platform engineering and how Portworx can help. You can scan this QR code and it'll take you to a video and a web page where you can learn more about it. Also, if you want to know any more about Portworx, obviously you can contact John or I. We'll be happy to talk about it. But if you want to do some of this on your own, check out our blog at portworx.com/blog. We're constantly writing new things there about different ways you can manage your data in Kubernetes. And we've got a YouTube channel as well where we've got a lot of videos, including the one you just saw on PX Delivery if you need to show that to somebody. But there's a QR code there as well for our IDC Spotlight. So if you're looking to see that IDC MarketScape and where we landed, you can grab it from this QR code as well. John, you got anything else to add?
Yeah, I mean, just if anyone's curious about this, obviously you could also, look up portworx.com. There's free trials. There's ways to get started. We do have teams around the globe that can help you get this, in a POC or anything like that. If you have a real use case that you're really, really interested in, we're here to make sure you're successful in doing your Kubernetes project.
Cool. And I think with that, we've got a little bit of time left. Let's open this up for a few questions. I wanted to thank everybody for their time if they're got to drop, but thanks for joining us. And if you don't have any questions, we'll see you later. If you do, we'll stick around.
All right. Yeah, great presentation and discussion there. Although I have to say that demo, but the barbecue place may be pretty hungry. But we've got just a minute or two left for questions here. Eric, thanks for your answers that you submitted already to questions from Sean and Cal and Allie. We've got another one here from Allie, who's asking, with the increasing adoption of cloud-native technologies and containerization, how does Portworx approach simplifying the user experience and management overhead for DevOps teams and application owners who may not have deep storage expertise? Any thoughts on that one?
Yeah, great question. Hopefully, as part of the presentation, I know this question was asked early on, hopefully some of this got answered where we're simplifying the environments that you're actually deploying to. So not necessarily anything specific to Portworx, but the new methodology on how you can manage your Kubernetes clusters across environments should simplify things for your DevOps teams As far as it goes with like self-service and reducing toil for that matter, your storage cluster deployed in Kubernetes can be set up with storage classes. So really, anytime you wanted to deploy a new container manifest or whatever, and you need storage for that container, and maybe you need some that are encrypted and some of them that have REPL2 volumes and some that are REPL3 volumes, you can create all those permutations that you want to by customizing a Kubernetes storage class. And then at that point, it becomes pretty self-service for anybody who's got access to the Kubernetes cluster to get whatever services they're looking for from the Portworx storage cluster, whatever those features might be.
Okay. All right. Super. Well, Eric, unfortunately, it looks like we're just about out of time here, but thanks to you and John for just putting together a really informative presentation and for all your insights here and in the Q&A console. Really appreciate your time today.
Thanks for having us.
All right, and before we wrap up, we have one more piece of business. That's the Amazon gift card prize drawing, and the winner of the $250 Amazon gift card today is Robert Eng from Minnesota. So congratulations to Robert. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Portworx again for making this event possible. And thanks as always for attending and for the great questions that you guys submitted. That concludes today's event. Have a fantastic rest of your day.